Good morning, my YouTube viewers. In this particular video, what we're going to be talking about is estimation with inferential statistics. And so what that does is it makes inferences about population parameters on sample data, including hypothesis testing and confidence interval estimation. And so we're going to write a program or review the code of a program that proves estimation with inferential statistics. And before that, we do that, what we're going to need to do is we're going to need to import 3 libraries to execute the program. So we're going to import NumPy as NP, which is the numeric library. And then we're going to import scipy.stats as stats, which is the statistical module of the scipy library. And the scipy library is for scientific purposes. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. And then so what we're going to want to do is we're going to want to generate synthetic data, e.g. test scores of students. So the first thing that we're going to do is we're going to set our seed. The reason why you set your seed is so every time you run the program, it initializes to the same values. So you type np.random.seed brackets whatever number you want inside the brackets. So now we set our population mean as being 75, which is the mean test score. Population standard deviation is 10. Sample size is 30. And the sample data is np.random.normal brackets loc equals population mean, comma, scale equals population standard deviation, comma, size equals sample size. So now we do some hypothesis testing. It's a one sample t-test. So the null hypothesis means a population mean is 70. And an alternate hypothesis is the population mean is not 70. So you're looking for a population mean of 70. So the hypothesized mean equals 70. The sample mean equals np.mean brackets sample data. The sample standard deviation equals np.std, comma, no, brackets, sample data, comma, DDOF equals 1. And your DDOF is your degree of freedom, Standard error equals sample standard deviation divided by the square root of the sample size. Your t statistic equals your sample mean minus your hypothesis mean divided by the sample standard error. Your p-value, which is a probability, equals stats.t.sf. SF stands for survival function, brackets np.abs, brackets t statistic, comma, df equals sample size minus 1. So that's going to be 29 times 2. So that's a two-tailed t-test where you're going to get the p-value from that. We're going to calculate a 95% confidence interval. Confidence level equals 0.95. Degree of freedom equals sample size minus 1, so that's 29. Confidence interval equals stats.t.interval, brackets, confidence level, comma, degrees, df equals degrees of freedom, comma, loc equals sample mean, comma, scale equals standard error. So now we're going to print the results. We're going to print the sample mean, the t statistic, the p-value, and the 95% confidence interval. So your sample mean is 73.12, and you were looking for a mean of 70. Your t statistic is 1.9. Your p-value is 0.0677, so that's greater than 0.5. and your confidence interval is 69.76 to 76.48. But since your p-value is greater than 0.5 because your alpha is going to be 0.5, that means that you're going to fail to reject the null hypothesis. So that means that there's no significant difference between the two values, between the true hypothesis and the true mean and the hypothesized mean. So now what we're going to do is we're going to plot it onto a graph. So plt.figure brackets fig size equals 6, 4. We're going to create a histogram of the sample data. plt.hist brackets sample data, bins equals 10, color equals light blue, edge color equals black, alpha equals 0.7, label equals sample data. So we're going to add vertical lines for the confidence interval and sample mean. So plt.axfig line brackets sample mean, color equals blue, line style equals dashed, line width equals 1.5, label equals sample mean. And then plt.axfig line brackets confidence interval 0, color equals green, line style equals dashed, line width equals 1.5, label equals lower confidence interval for 0. plt.axfig line brackets confidence interval 1, colors equals red, line style equals dashed, line width equals 1.5, label equals upper confidence interval 1. plt.axfig line brackets hypothesized mean, color equals blue, purple, line style equals dotted, line width equals 1.5, label equals hypothesized mean. So now we're going to add titles, labels, and a legend to the graph. So the title is confidence interval and hypothesis testing. The X label is value, e.g. test scores. The Y label is frequency. You get a legend, you get a grid, and then we're going to show it. So this is the graph that it makes. It says confidence interval and hypothesis testing. So you see that the blue bars is your sample data. The sample mean is in blue and it's 73.12. The lower confidence interval is in green and it's 69.76. The upper confidence interval is in red and it's 76.48, and you can see that the hypothesized mean is 70. So the hypothesized mean is what you wanted, which was a dotted line of 70, but the sample mean was 73.12. But when we tested our p-value, the p-value was greater than 0.05. So that means that we would fail to reject the null hypothesis, because the null hypothesis would be there's no significant difference between the sample mean and the hypothesized mean. And the alternate hypothesis is there is a significant difference between the sample mean and the hypothesized mean. So for the purposes of this test, there's no significant difference between the hypothesized mean and the sample mean. So that concludes this video on estimating for inferential statistics. So the next video is going to be in regression analysis, and I hope you decide to watch it.